Node.js microservices from zero to cloud series. Viewers, in modern microservices and API gateway architecture, a single user request does not go to just one server. It actually may travel through multiple systems. For example, a request might go from Cloudflare API gateway to the authentication service, then go to order service, then to payments, then to database or a cache, and maybe even a third-party API. Now here is the real problem. When something becomes slow or broken, traditional logs cannot tell us that where did the request go, which service was slow, where exactly did it fail, and how often is this happening. And viewers, this is exactly where observability comes in. Now, what is observability? Viewers, observability means being able to understand what is happening inside a distributed system just by looking at its outputs. In simple words, it means we should be able to see what is happening inside our system without guessing. Observability is built on three pillars. Logs tell us what happened. Matrices tell us how often and how fast. And traces tell us where a request went. And in a microservices world, traces are absolutely critical. Without tracing, microservices simply cannot survive in production. So viewers, we see what is distributed tracing. Distributed tracing answers one powerful question, and that is, what exactly happened to this specific user request? Viewers, instead of seeing logs from individual services, we see a full journey. For example, we can see something like the API gateway took 120 milliseconds, the authentication service took 40 milliseconds, the database took 20 milliseconds, the order service took 60 milliseconds, and the payment API took 45 milliseconds. This entire journey is called a trace, and each individual step in that journey is called a span. So a trace is the full story and spans are chapters of that story. Now viewers, we look at the OpenTelemetry. OpenTelemetry, also called OTel, is the global standard for observability. It was created by combining two earlier projects, OpenTracing and OpenCensus. Viewers, today it is backed by companies like Google, AWS, Microsoft, Meta, Cloudflare, Grafana, and Netflix. Viewers, Hello viewers, welcome back to Node.js microservices from zero to cloud series. Viewers, in modern microservices and API gateway architecture, two special HTTP headers, trace parent and trace state. These headers travel with every request. So when Cloudflare sends a request to your Node.js microservice, it sends something like trace parent with some ID. This tells every downstream service this request belongs to this trace. This is how all microservices stay connected to the same request. Now viewers, with all this, we find out what is the role of Cloudflare. Viewers, in our architecture, Cloudflare workers act as the API gateway and the root of the trace. It is the very first system that receives the user request. So it must create a trace, attach the trace headers, and pass them downstream. That makes Cloudflare the root span of every request in our system. Next, we see what is Grafana. Grafana is the visualization layer. It is what we use to see what is happening. Grafana allows us to search traces, click into span, see latency, see failures, and filter by service, user or endpoint. Grafana itself does not collect data. It reads from backend like Tempo for traces, Prometheus for matrices, and Loki for logs. Next viewers, what is Grafana Tempo? Basically, Tempo is our distributed tracing backend. It stores trace IDs, spans, timing, and errors. OpenTelemetry sends all tracing data to a Tempo. Grafana then queries Tempo and shows us the complete request flow. And viewers, in the last, we see how everything fits together. So the full pipelines look like this. Cloudflare worker creates the trace. OpenTelemetry collects and propagates it. Grafana Tempo stores it. Grafana UI visualizes it. And now you can debug real production issues. But viewers, why this matters so much? Viewers, without observability, you build microservices. You deploy them, they fail, and you guess. But with observability, you see reality, you debug in seconds, you scale confidently, and you look like a senior cloud engineer. This is what separates junior developers from real cloud engineers. I hope viewers, this video has cleared your concepts about observability. In the next video, we will implement all these features. So don't forget to like and subscribe the channel CodingMavrick. Hello viewers, welcome to Node.js Microservices from Zero to Cloud series. Today we are going to implement observability and distributed tracing across multiple services using OpenTelemetry, Grafana and Tempo, all the way from local Docker deployment to cloud. Viewers, to get basic understanding about observability, you may watch my previous video on my channel CodingMavrick. Now, in this episode, I will deploy services and API gateway on Cloudflare and Railway Cloud. So if you have missed anything in the previous videos, you may watch this episode. So viewers, stick around and don't go away. Viewers, in today's project, we will follow the complete request journey along with observability and OpenTelemetry tracing implementation. Today's sequence would be as follows. Viewers, the client first sends a login request to the API gateway. Then the gateway forwards it to the auth service, which verifies the credentials and returns a token. That token is then stored on the client and used for future requests. When the client requests order data, the API gateway validates the token again through the auth service and then forward the request to the order service. Finally, the order service responds with the protected data which flows back through the gateway to client, completing the full microservices workflow cycle. Here, each service including gateway, auth service and order service will carry tracing capabilities using OpenTelemetry. So viewers, create core project structure starting from root package as Cloud Observability, and inside it create API-gateway, auth service, order service, payment service and observability packages. Now start coding in observability module. Viewers, create packages as Grafana and Tempo inside the observability module. Also create docker-compose.yml file. It should be on the root of the module. Set the configuration inside Docker file. Viewers, this configuration is freely available on my GitHub. Next, create tempo.yml file and put the HTTP listen port and distributor setting. This file is also available on the source code. Now viewers, go to terminal and run the command docker space compose space up. But viewers, you can see it has been crashed as there is no Docker installed on local machine. So first install Docker Desktop from its official website. After installation, continue without sign up. Now inside terminal, run the command docker space dash dash version and it is showing 24.0.6 version. Now run the command docker space compose space up inside the observability package. Viewers, there is a small issue and that is we have tempo entry in our Docker Compose file as tempo.yaml, but our actually created file is tempo.yml. So change its extension and again run the command docker space compose space up. So viewers, when we run docker compose up command, Docker first reads our docker-compose file and identifies two services, Tempo and Grafana. If these images are not already available, Docker automatically pulls them from Docker Hub. Next, Docker creates a private internal network so both services can communicate with each other. Then the tempo container starts. Our local tempo.yaml file is mounted inside the container, allowing the tempo to run with our custom configuration. Multiple ports are exposed, so applications can send traces using OTLP and Grafana can query trace data. After that, the Grafana container starts. Grafana runs internally on port 3000, but we expose it on port 3001 so we can access the dashboard from our browser. Once both containers are running, Grafana and Tempo are automatically connected through Docker's internal network. Grafana can communicate with Tempo using the service name Tempo, not the local host. Docker Desktop Backend may ask for Windows Defender Firewall to exclude its services to allow the access. Viewers, at this point, our local observability environment is fully ready. Tempo will collect and store traces, while Grafana will provide visualization and trace exploration. Now run the command in PowerShell as docker space ps. It will show the status of local running Docker instance and deployed apps on it. And viewers, you can see observability is up and running on Docker, and Grafana is available on port 3001. Viewers, you can also see the Docker desktop interface, and there is also instance of observability that is up and running. So now run the Grafana UI in browser using URL localhost port 3001. Now log in the page with username and password. Give admin as username and password and skip changing password option. Now from dashboard we create Tempo data source in first step. So click on Data Sources tab, then scroll down to Tempo in Distributed Tracing section. Set the connection URL as http://tempo:3200 and scroll down to bottom. Now click Save and Test button. It shows data source is working. Viewers, in next step, we will instrument our authentication service. We integrate the OpenTelemetry SDK into our auth service, add tracing to the login and verification endpoints, and send these traces to our local Grafana instance. This allows us to see every request, each span, and the relationships between them. Now go inside the auth service package and create node project using command npm space init-y. Next install Express using command npm space install space express. Then install OpenTelemetry inside the auth service. Viewers, OpenTelemetry is an open source observability framework providing a unified set of APIs, SDKs and tools to instrument, generate, collect and export telemetry data such as logs, matrices and traces. It helps developers to understand and troubleshoot software performance and behavior, especially in complex distributed microservices. Viewers, first of all, we will install OpenTelemetry API using the command npm space install space @OpenTelemetry/API. Next, install core OpenTelemetry engine SDK using the command npm space install space @OpenTelemetry/SDK-node. Next, install OpenTelemetry Auto-instrumentation, which is used to auto-trace HTTP requests and to send traces to Tempo. Viewers, we will use the command npm space install space @OpenTelemetry/auto-instrumentations-node. Viewers, these are the three necessary parts of OpenTelemetry framework. Now create a file tracing.js inside the auth service for enabling OpenTelemetry functions inside the auth service. Here we import the Node SDK from OpenTelemetry, which acts as the main engine responsible for managing tracing inside Node.js application. Next, we import automatic instrumentations, which allows OpenTelemetry to automatically trace common libraries like Express, HTTP, Axios, database drivers, and many more without writing manual span code. Next, we import the OTLP HTTP trace exporter. This exporter is responsible for sending trace data to an external backend like Tempo or Grafana Cloud using the OTLP protocol over HTTP. Next, we import the OTLP HTTP trace exporter. This exporter is responsible for sending collected traces outside our application to the systems like Tempo, Grafana Cloud, or any OTLP compatible backend. Next, we configure the trace exporter. We will tell OpenTelemetry to send all traces using OTLP over HTTP to the Tempo service running inside the Docker. Port 4318 is the standard OTLP HTTP port and /v1/traces is the official OpenTelemetry ingestion endpoint. Next, we create a new OpenTelemetry Node SDK instance. This is where we configure how tracing should work in our service. Next, we set trace exporter with exporter. Then we enable automatic instrumentation for the entire node application by setting get node auto-instrumentation. Once this is active, OpenTelemetry will automatically create spans for incoming HTTP requests, outgoing requests, and framework level operations. Calling SDK start activates OpenTelemetry, and in the end log the message about successful tracing initialization. Viewers, from this moment onward, every request handled by this service will automatically generate traces and send them to Tempo. Now viewers, create the auth service by creating index.js file. Next, /tracing is intentionally placed at the very top of the file, before the express, before the routes, before anything else. This is required because OpenTelemetry must hook into Node.js internals before any framework loads. Next, we import Express, which we will use to create our authentication microservice. Then we create our Express application instance. Next, we allow Express to read JSON request bodies, which is required for login request. Next, we define the login API endpoint that will be called through the API gateway. We extract the username from the incoming request body. Next, we simulate authentication flow. There is no database yet. It is just for understanding tracing. We intentionally add an artificial delay to simulate real-world processing time, such as database calls or password verification. After the delay, we return a mock authentication response with a status OK, username, and fake JWT token. 100 millisecond delay helps us to visually see latency in the Grafana traces. Next, we start the authentication service on port 3000. Then log message to confirm that our auth service is running and ready to accept request. Now viewers, run the auth service locally using command node space index.js, and it has showed the success logs of auth service start and tracing initialization. Now in Thunder client, set the URL and set header content type with the value application/json. Set the body with username and send the command. And viewers, you can see service has returned the data we have set previously. Now viewers, test the service with observability on. For this, first down the Docker and again make it up and run the auth service again. Then send the Thunder client post request again. Viewers, you can see Docker is running the observability instance. Now open the local Grafana UI, log in with the password. This time you have to create data source again, as when we restore the Docker, it resets everything to default. Now after that, go to Explorer and then Search tab. Then click the Run Query button from right top. Grafana UI has loaded the traces in the trace table. Viewers, trace table has trace ID, start time, service name and request name. But viewers, you can see that service name is missing from the trace. So we will set the service name along with service version for OpenTelemetry so that it may present it in every trace in Grafana UI. Viewers, easiest way is to pass them as environment variable through terminal command. It should be before the node space auth service start command. Now again open the Grafana UI and its Explorer and query the traces. And you can see Grafana has loaded the service name with every trace. Viewer, we may summarize the trace info as trace ID is for unique identification, span shows each step of the request, duration and time are for performance analysis, parent-child relationship and context propagation are for presenting relationship of multiple traces and spans. Now viewers, we will adjust our auth service to deploy it on Railway Cloud so that we can visualize the tracing in cloud environment instead of local observability inside the Docker. For this purpose, we will also link it with GitHub. This is for the Railway Cloud, which pick the GitHub CI/CD pipeline for continuous deployment of any source code. deploy the auth service on Railway Cloud. First click on the Create button on the right top of Railway Cloud dashboard. Then click on the GitHub repo option. Select Own repo if available. Otherwise, link it first. Viewers, Railway Cloud would pick the whole repo where multiple services may exist. So from